I'm going to talk about the area of a parallelogram and how to find the area of a triangle. First, we'll talk about parallelograms and how we find the area. Suppose we want the area of this parallelogram, and we have the base. Now, I claim that the area is just base times height, and the height is this piece right here. Okay. Now, it's a parallelogram. That means this side and this side are parallel and they're the same lengths. We are going to take this piece right here, I'm going to cut it away. I'm going to put it right here. I'm going to put it right there. And as though I didn't prove it, it's going to fit like a glove. It's going to fit like a glove. And this line is meaningless at this point. And remember, this dotted line I said was H. This is H. And this portion that I cut off, this portion that I cut off, I put here. So B, just extend it. This whole thing is B. It is a rectangle. This is a rectangle. And the area of a rectangle is base times height. Just like I said it would be. So if you have a parallelogram, and you have the base, and unfortunately this doesn't look too parallel, so let's take care of that. You have this parallelogram. If you calculate the height, you could calculate the height by extending the base, and from this point going down at a right angle, it's going to be the same height. It's going to be base times height. Now, what if you have a triangle? What is the area of a triangle? Now, I maintain that every triangle is half of a parallelogram. For example, if you have an obtuse triangle, that is, this is more than 90 degrees, you could extend it to a parallelogram. And all I did is I took this area and I flipped it across this line. And I came up with that area, that triangle. Those two triangles are exactly the same. But it's a parallelogram now. Well, the area of that parallelogram, according to our last theorem, is base times. You might have to extend the base, but don't extend the length. Don't say now B is this long. No, that's not true. You might have to extend the base to find the height, because you have to come down at a right angle. That's height. That's the area of that parallelogram. Well, if I cut it in half, I'll get half the area. Oh, perfect. That's the area of the triangle. If their triangle is acute. There's my parallelogram. This side and this side are parallel. This side and that side are parallel. There's my parallelogram. The area of the parallelogram is the base times that height. But that's the area, like I said, of the parallelogram. But this line cuts the parallelogram into two equal parts, two congruent parts. Okay, you should prove that. So, just this area, which is what I wanted to know initially, is 1/2 base height, or base height over 2. Okay. Now we have the two formulas, and it wasn't just given. We argued it through somewhat, and we're ready to answer these problems. We have all our ammunitions we need to answer this. Very basic problem. You have a triangle. The base is 30 millimeters, and the height is 15 millimeters. And I have to tell you it's at a right angle. Okay, so the area is the base times the height divided by 2. And 2 goes into 30 15 times. 15 times 15, 225. Times millimeter times millimeter is millimeter squared. 225 square millimeters. Now, how about we have this triangle? I tell you that this is 20 inches, and this is 15 inches, and I tell you that this distance, which is at a right angle, is 16 inches. This is the altitude, because it met one of the sides at a right angle. And the altitude, or the height, and the base must be at a right angle. That is, this is the base. Please, please do not call that the base. It's 15 inches, the base, times the height over 2. 2 goes into 16 8 times. 15 times 8, 120. Inch times inch, inch squared. 120 square inches. Now, for the record, let's think about something else on this problem. Okay, I could have given you this altitude as well. And if I'm not mistaken, it is 12. So I can use this as the base. So the area is 20 inches by 12 inches divided by 2. And 2 goes into 20 10 times. So you have 10 times 12, 120, times inch is square inch. Exactly the same area. Of course you're going to get the same area. How, what good would it be if the formula that we use to calculate the area of a triangle gives us different answers? And again, what does it mean that this triangle has 120 square inches? Well, again, you take 1, 2, 3, 4, 5, 6, 7, I don't know, 8, 9. Yeah, you put in some squares, and then you're going to have, or you cut out squares. You cut out perfect squares. No exaggeration at all. They have to be perfect. And then you're going to have stuff left over. You're going to have this stuff, and let's suppose, for argument's sake, you cut out 111 square inches. 111 perfect squares. Well, what's left over, it's going to be 9 more square inches for a total 120 square inches. Put the pieces together, you will get 120 square inches. I know you will, because it's half of a square. Sorry, it's half of a rectangle. It's half of a rectangle. What does that mean? Well, again, if you have this triangle, you can go parallel to this side and parallel to that other side, and now you have a parallelogram. 2 times that area equals that area. But this area, the one I just drew, it's the same as cutting this off and putting it here. That is, it's the same as this rectangle. Let's get rid of that side. Okay, so basically what I could say is divided by 2, divided by 2. The area of this triangle here is this area, which I think you can picture as squares, but half as many. If you see that, then it won't puzzle you like, come on, you know, this stuff is hard enough, but how are they getting squares out of triangles? Well, cut and paste. That's literally how they're doing it. Okay, here's a good problem. You have a rectangle with a triangle on top of it. It's 3 by 5. And I tell you the height is also 5. So what is the complete area? Well, it's this area, which is 3 times 5, 15 square units, plus the area of the triangle. The base, the same as that one, it's 5 units times the height, which is also 5 units, over 2. It's 15 square units plus 25 over 2 square units. 25 over 2 is 12 and a half. And when you add 15 to that, you get 27 and a half square units. So there's an example where when you partition, you get a triangle and a rectangle as well. Do one more problem. How about this problem right here? You have this big triangle. You put a square in. And you go like this. And you go like that. And I want to know what this area is. And if I said you make a square, that wasn't true. Suppose this is 3 by 4 by 7 by 5, or make it 6. Okay. 7. So what I'm going to do is I'm going to find the big area. I'm going to find the big area. And then I'm going to take away the area of this rectangle up here. Let's call that region 1. I am then going to take away the area of this rectangle, call it area 2, and then I'm going to take away the area of this triangle here, call that area 3, and then I'm going to say, wow, look at this. I have the exact area that I'm asking for. So the area that we want is the total area minus area 1, and then I went into regular digits, not Roman numbers. Area, because the total area minus the first area plus the second plus the third. Well, what is the area of the big triangle? Well, the base is 9 times, well, I'll give you this as a right angle. So the height is 7 plus 4. It's 11. That is, it's 99. Minus, what is area 1? Well, this was given to be 3. Just look right underneath it. So this is 3. The base is 3 times the height, 7. That's also a right angle. 7. So right angle here and a right angle here. So it's 3 times 7 over 2. Plus the area of region 2. This rectangle. Well, it's 3 by 4. 12. Plus the area of region 3. It's the triangle. It's the base, which is 6, times the height, which is 4, divided by 2. 2 goes into 6 3 times. So the final answer will be 99 minus 21 over 2 is 10.5 plus the 12 plus another 12. It's 99 minus excuse me. It's 99 minus what's in the brackets. 10 plus 12 plus 12 is 34 plus the half. This is 64.5. You have 99 and you take away 34.5. You have 66.5 square units. That's what this is. Understand subtraction? This is piece of cake. Okay, that completes the section for finding the area or areas of parallelograms and triangles.